All right, today we're going to be talking more about binomial settings. In today's lesson, though, we're going to be talking about women's soccer and talking about how successful they are and just the amount of goals that they score. So, based on penalty kicks. So, if you take a look, it says whichever team makes the most penalty kicks wins. We make 60% of our penalty kicks. What are the chances that they win the game? Is this a binomial setting? So you need to check your bins. Our lovely acronym for how to tell if something's binomial or not. So binary, yeah, well, you either make or miss your shot, right? Independent, well, one kick doesn't change the next kick, right? So the number, you need a set number of trials, which is 5. We said that there are only 5 players who get to kick. And then S stands for same probability. In this case, that probability is 0.6 of making those shots, right? So we hit bins, so this is a yes. Right? Woohoo! All right, so if we were filling in the probability of each individual event happening, so what's the probability the team scores 0 goals? I'm going to zoom in real quick. We're going to use the formula that we talked about yesterday. So the number of combinations, we have 5 kicks. What's the probability they score 0 goals? So a make, that means 0 makes, and then a miss, 5 misses, right? So if you take a look at your calculator, I wanted to show you guys where to find this again. So if you go to math, maybe this will show better. Let me zoom out. Let me just refocus. Okay. Ooh. Sorry, guys. Okay, maybe this will work, maybe it won't. Nope. That was a fail. Sorry, guys. Okay, you're just going to have to deal with it being a little blurry. So you're going to hit the math button, and then you're going to have to slide over to probability, and then you're going to see NCR. So that's the number of combinations, so the number of ways that will happen. So you're going to fill in N, and you're going to fill in AP Statistics, it's K, which is 0. So you're going to hit that, and that would give you 1. And then you're going to multiply that by 0.4 to the 5th power. And then anything to the 0th power is 1, so I don't have to worry about that, right? So for this first one, I'm going to get 0.01024. Right? And then we're going to keep going with all of these, right? So I could do this again, 5C1 times 0.4 to the 4th. 0.6 to the 1st power, right? So once again, I can go to math, probability, NCR, and then I would have 5 kicks, and I'm only making 1 of them, so that number is 5, and then I get to multiply that, so 5 times 0.4 to the 4th, right? And then times 0.6 to the 1st power. And then, boom, I got my answer, 0.07, blah, blah, blah. .0768. Right? All right, and I also wanted to show you something cool on your calculator. So you're going to see what I did is I have that NCR function, and instead of hitting enter to find my answer, what I did is I sort of typed in the rest of the formula. And then instead of retyping this in over and over again, you can hit the second button, so the blue, and then enter. And then that entry that you just typed in pops right back up again. And all I have to do is go and highlight and change the values that I want to change. So those exponents. And then the number of successes is changing, right? And you can do that pretty quickly. So you're going to see that I'm going to get my next value here. And then I can keep changing those over and over and over again. And it makes everything just kind of flow a lot faster. So anyway, what you're going to have to do next is it says find and interpret the mean of the probability distribution. So if you remember how to find the mean, I believe this was in 6.1, that's the sum of the individual x values times their individual probabilities. And usually to show my work, I take my x values times their probabilities, and then I just start adding. I usually do like the first two, and then the last one. Or, oops, it should be a 5, not a 6, sorry. 5, and then 0.0776. Right? And if we were to do that, you're going to see that on average, we should make about 3 goals. So after many, many shots, or I'm sorry, after many, many shootouts, we would expect to score about 3 goals. And that should be pretty self-explanatory, right? Because if you remember, we talked about the mean being equal to the number times the probability a long time ago, right? This is only true, though, if each event has the same chance of occurring. So that's just a little throwback to you. The main one that I wanted you to focus on was this guy right here, right? And if you calculate it that way, you're going to end up with the same answer, actually. What you are going to find next is to find and interpret the standard deviation of this distribution. Your standard deviation is actually equal to the square root of n times p times 1 minus p. And this should sort of make sense because n is your sample size. P is the probability of success, right? And then 1 minus p is the probability of failure, right? So once again, you have your standard deviation. You can calculate this by taking the square root of n times p times 1 minus p. This formula is on your formula sheet that I handed to you guys a long time ago. If you don't have it, let me know and I can send you a PDF version, right? And you're going to find these formulas under binomial, okay? But once you have this standard deviation, you're going to find that it's 1.095 watts. They're goals. Remember, you need units for these. And then your interpretation, we expect the number of goals to vary. See context, right? By 1.095 goals from the mean of 3 goals. Right? So, what's the probability that the team scores at least 1? Remember, at least 1 is the same as 1 minus the probability of none. So if I were to do that, we already know what the probability of none is, right? We already calculated that up in that table earlier. So the probability that the women's team scores at least 1 goal, well, that's like 99% almost, right? So once again, I have probability notation. I showed my work, and I have my answer. If the other team is expected to make 3 goals, what is the probability that the USA women's team wins? So we expected 3, right? So to win, we need 4 to 5 goals, right? So we need to find the probability that we score more than 3 goals, right? Which means we can add up the probability that we scored 4 and the probability that we scored 5. So we can do that, 0.2592 plus 0.0776, and that gives us 0.33696 as our chance of the USA soccer team winning in this shootout, right? Okay, so what we're going to find is some really cool stuff with binomial distributions, and I'm going to show you some calculator stuff as well that's really fun to work with. So yeah, stay tuned. So if we're describing binomial distributions, their shape, when you're talking about the shape, you should draw a histogram. You should have all the probabilities in your probability distribution, this binomial distribution. You can draw a histogram with those, right? And then you should just be able to describe that histogram. In order to find your center, that formula, remember, it's easier to work with, is just n times p. That number of trials times the probability, sort of like an expected value, right? And then the spread, or the variability, is talking about the standard deviation, which we do n times p times 1 minus p, and then we take the square root, right? And when you interpret with your interpretation, something that I didn't do is you need to mention the number of trials, right? So, for example, the 5 kicks. So, when we kick 5 times, we would expect to have an average of 3 goals made, right? So, we should have made that interpretation instead. And then there's some calculator stuff on page 394. You can check it out in your book. It will make your life 10 times easier to understand this. So if you go to second vars, which is like your distributions, you're going to find this thing called binom PDF. That P stands for precise. So when you're looking for something like the probability x is equal to 3, you would use binom PDF. And then there's this thing called binom CDF. And then that C stands for cumulative. So for example, if I was looking for the probability x is greater than or equal to 3, right? Or I could do less than or equal to 3. So please check out your textbook on that page. It will do a little bit more work for you, but remember, you need to describe, or at least tell me, I think it's N, P, and X. Sorry, I forgot the third thing. You're going to need to label the parentheses as well. Okay, we're going to try your check your understanding on your own, and then we'll come back. You might need some help. It says use technology to make a histogram on number 2. Just a quick hint before you try this on your own. You might want to try binom PDF with N, P, and X. Remember, 10 questions. The probability you get it right is 0.2 because there were 5 options. And then X you can fill in yourself, right? That will help you get all of your individual probabilities. All right, and then we'll check back in. All right, so looking at this Mr. Miller's question, the first thing is talking about bins. Independent, so when you're guessing, each question's independent of the next. You would assume that. The likelihood you get one doesn't affect the likelihood you get another. When you're talking about using technology, like I said, use this calculator function. You can get all of these individual probabilities really quickly. So if you were to do that, so second vars in your distributions, you got to find binom PDF. Remember, you're looking for precise values, right? So the number of trials is 10, the probability is 0.2, and the x value, let's just say 3. You can paste that, right, and get your probability. But if you go to second enter, all you have to do is change that x value and keep getting the next values. Second enter, I didn't have to go